Alright, so I'm gonna do. We're kind of doing like pre-derivatives today. Starting to start them. And I'm gonna do a couple problems up here on the board, but I realized now that I've printed that and given it to you, I didn't leave you very much space. So I don't know if you want to get out your notes or write small. It doesn't matter. I apologize for not leaving more space. But here we are. So. Okay. Oh, give me a second here. I did not. It gets old.
Oh no.
It's so slow. I think it better if it was like a No, it didn't work.
No, you're just writing yourself.
Oh, no, I'm good. These are all the same thing. Average rate of change, slope of secant line, slope between 2 points. Like we're literally going to use the slope formula today. Pre-algebra, y2 minus y1 over x2 minus x1. Freaking me out. So the idea of calculus is eventually we want to be able to take the slope at 1 point, which is goofy because you're used to like, well, I need 2 points. Y2 minus y1 over x2 minus x1. So we're kind of working up to that. So if I look at number 1, for example, let's use that as an example. -4 and -1 are both x values. And we are asked to find the average rate of change or the slope of the secant line. So that's the slope of this line. So up until basically today, I don't know what you've done in physics, but you needed 2 points to find the slope of the line. That's what we're going to do. We're going to find that slope. But just to start talking about what's happening, or where we're headed, if I said I want to find the slope at 1 point, which technically you can't do, you need 2 points, but I can approach 1 point, so I can limit it. But let's say I want to find the slope when x equals 0. So the slope of this line right here. So at x equals 0, if I was going to do this. So imagine you're driving your car around a curve, and then you get to that spot, and your wheels kind of catch, and you can't turn, and you're just stuck going with the direction that it flowed. This was actually discovered by, I think it was Newton. It was like doing something to calculate like something around the sun, and he was like, well, if the gravitational pull stopped pulling, we would just float off, and then he started finding, and he just discovered calculus. That's what I would have done. Yeah. Oh, that's just mostly because I'm an idiot. Yeah. So right there. So where we're headed is this a good approximation? So then the slope where you're like floating off into space line is more like that. Is this a good approximation of the slope at x equals -1? Not bad. If I brought these 2 points closer together, let's say I went between -3 and -1, did my approximation of that precise slope just get better or worse? It's hard to tell with this big slope. Let's say I'm looking at it like this, and I want to know the slope right there at 1 point. So if I'm curving around the sun, but then all of a sudden the sun's gravity stops pulling me, and I just float off into space. So I'll go kind of like that way, right? So if I use the slope between these 2 points to try to estimate that, it's not very good, right? But if I bring this point closer, did I just get better or worse? I just got better. Bring it closer. Did I just get better or worse? Better. Bring it even closer. Better or worse? Better. So if I let the limit of the distance between those 2 points approach 0, we're still technically finding the slope between 2 points, but they're so close together, it's basically 1 point. And that's what a derivative is. Instead of needing 2 points to find the slope, we can find the slope instantaneously at 1 point. So do you guys talk about like instantaneous velocity in physics? You got them there? Kind of. So you probably do like average velocity, right? Like between 2 points. So calculus allows you to find instantaneous velocity at one specific point. So that's what derivatives are. We're not doing derivatives yet, but we're just kind of like building up so we can use the concept of what's happening. So what's happening here is I got a point at -4, comma, I don't know, I'll find out in a second. I got a point at -1, comma, I don't know, I'll find out in a second. And I'm going to find the slope between those 2 points. And that is a good approximation for the slope at, I don't know, like -2.5 would be right in the middle. The approximation would be better if I brought these 2 points closer and closer and closer, but we're just starting off with the idea like, okay, let's get kind of close, find the slope, and then we'll start learning how to find that 1 point. So, your job is to find the y value of these 2 points. So plug into there. So this one is -1 over -4 minus 1. So that would be positive 1/5. Or 0.2. If you want to do that way. Plug -1 in here. -1 over -1 minus 1. So that would be a positive 1/2. And then literally it's just the slope. Rise over run, so y2 minus y1. That's squared. So y2 minus y1 over x2 minus x1. So derivatives are literally just slope. It's just your 2 points are really close together, so it's basically like it's 1 point. So I'm going to use this as my point 1 and this is my point 2. So y2 is, let's say, point 2. I'd rather work in decimals. Minus y1, 0.5, -4, minus -1, -0.3 over -3. That is not an incorrect answer. That's totally fine. It's just kind of weird to leave the decimal in there. So your answer sheet will probably say 1/10. The negatives will cancel and they would like reduce it. I don't know why reduce it. Because this is really like 3 over 30. I'll multiply both of those by 10s. And then if I reduce that, it's 1/10. So if I were to ask like where we're headed, we're not there today, but if I said approximately what is the slope right in the middle of those 2 points at -2.5. That, for now, would be your best guess. You want like a little bit on each side of it, one slope between those, and that's like close enough for now. Tomorrow will be better. Does that make some sense what I'm trying to get at? Question number 1 here? Number 2. Well, that's the same thing. Let's do, it's kind of the same thing. So we're going to just pick one. So 0, 3. So really this is trying to get at the idea of what is the exact slope at 1.5. That's not what I'm asking you, but that's like kind of what they're trying to gear you up for. Is, okay, let's just go like a little bit to each side and find the slope at that spot. But where we're really headed is at this spot, 1.5. If this is the Earth's path floating around the sun and the sun just stops working, we're going to head off on that line. Now I'm trying to estimate the slope of that line. That wasn't a very good one. Like that. So again, that's where we're headed, but you don't have to do that quite now. So I want to find that point, which is 0, 1, right? And then this point, which is 3, comma, if I plug 3 in here, 3 plus 1 is 4, so 1/4. on slope to it. It's really just slope. The more important thing to me right now is trying to get across the idea that we're really trying to narrow those 2 points. So that the 2 points we're finding the slope between are so freaking close together that they might as well be 1 point. So if I do my slope formula, 0.25 minus 1 over 3 minus 0. So like negative 0.75 over 3. So that's 1/4, yeah. Right. So you could like multiply these by 100 to get rid of the decimal and say, okay, that's negative 75 over 300. And then if you reduce that. But really, this is fine. I'm totally fine with that answer. The AP test would be totally fine with that answer as well. If it's multiple choice, they would probably put this. So you'd have to know how to work your way there. And if your response, you could just leave it. Does that make sense what I'm trying to talk about here? Questions? Go through another one? Gucci? Ryan, are you Gucci? That's what's most important. Ryan. Oh, like what? Are you Louis? Are you Kanye? Have you worn him yet?
Yeah.
You gotta show me. I've never seen him. Forgot I did. How do I know? Just listen to me. Who? Does he? Alright. He never speaks. Until I started talking about Pat last year, he wouldn't shut up. Yeah. Does he? Cool. Right?
That was so easy. Took like 10 minutes.
Does he talk outside of school? Or talk about that?
It's really like, it's really subliminal. I really like it.
Really what?
It's really subliminal. I don't know. Feels like
It's like a different
you
level.
feel like you're never really talking.